Good day, viewers. Welcome to the Physics Mind. Today, we will be looking at thermal conductivity, and we will be looking at some examples under thermal conductivity. So, let's dive into the examples. Okay, so we have a question here which says that the temperature difference between the ends of a conductor 38 centimeter long is 25 degrees Celsius. Calculate the heat energy per second passing through the conductor, given the thermal conductivity is 380 watts per meter per Kelvin, and the area of the cross section is 1.0 times 10 power minus 2 meters. Okay, so this is the question we want to solve. All right. So solution. Now, let's write down the equation for the thermal conductivity of a material. Now, from the equation of a thermal conductivity, we have the Q over T is equals Ka into T1 minus T2 over L. Okay, so this is the equation for the thermal conductivity of a material. So Q here stands for the quantity of heat that is being transferred from one body to another. And T here stands for the time taken for that heat to be what? To be transferred. So the whole of this quantity, Q over T, stands for the what? The time rate of what? Heat that is being transferred. So if the equation is given to us to find the rate of heat transferred, that means we are not just finding Q as a quantity, we're also not finding T as a quantity, but we are finding Q over T as a quantity. But if the question say find the quantity of heat, then we have to cross multiply and find Q as a quantity. So K here stands for the thermal conductivity. So, and whose unit is what? Is watt per meter per Kelvin. And A here stands for the area, which we know is in meter square. Remember that Q here is a quantity of heat, which is measured in joules. T here stands for the what? The time taken for the heat to be transferred, which the unit is seconds. And then T1 minus T2 here stands for the what? The temperature difference. T1 stands for the initial temperature and T2 stands for the final temperature. Of course, we know that heat is going to be transferred. So it means that the initial temperature will be greater than the final temperature. So that is why we have T1 minus T2. So T1 minus T2 here stands for the temperature difference, and then L here stands for the what? The length of the conductor, or the distance between the what? The ends of the conductor. Okay, so the entire quantity T1 minus T2 over L stands for the what? The temperature gradient. So if a question is given, find the temperature gradient, it means we are finding the whole of what? T1 minus T2 divided by L as a single what? Quantity. Okay, so back to the question we have that the temperature difference between the ends of a conductor is 38 centimeter long. So let's write down the parameters from the question. So we are told that the temperature difference between the ends of the conductor, 38 centimeter long, is 25 degrees Celsius. So that is to tell us that the temperature difference is 25 degrees Celsius. And that temperature difference stands for the what? The T1 minus T2. So we're indirectly saying that T1 minus T2, based on the question, is 25 degrees Celsius. And we are told that the ends of the conductor, 38 centimeter long, that is the what? The length of the conductor. Okay, so it means that the length of the conductor is 38 centimeter. But the SI unit of length we know is meters, not in centimeters. So all quantities must be expressed in their SI unit before they can be what? Be substituted in the equation. So we have 38 centimeter. We'll convert it to meter. We divide this by 100. So that will give us 0.38 meters. Okay, so we're asked to calculate the heat energy per second passing through the conductor. Heat energy per second. So what are we asked to find? We are looking for what? Q over T as a what? As a quantity, because that is the quantity of heat per second that is passing through the what? The material. So we are looking for Q over T as a quantity. And we are told that given that the thermal conductivity is 380 watts per meter per Kelvin, so that is the what? Thermal conductivity K, and is equals to 380 watts per meter per Kelvin. And the area of the cross section is this. So that is the area. So the area is 1.0 times 10 power minus 2 meters. Okay, so let's substitute in the equation to find Q over T, which we are looking for. All right, so we have that Q over T is equals Ka into T1 minus T2 over L. So since we are looking for Q over T as a quantity, we don't need to cross multiply. So this Q over T remains where it is. So Q over T is equal to K. What is our K? It's 380. Now multiply by the area, which is 1.0 times 10 power minus 2. Now, open bracket, T1 minus T2, which is the temperature difference, we are given to be 25 degrees. So we have 25 divided by the length of the conductor in meters, which is 0.38. Okay, so Q over T now becomes 380 times 1.0 times 10 power minus 2 times 25 divide 0.38. So I will use my calculator to obtain that. So I have 25 divides 0.38. So I have 65.79 approximately. All right, so Q over T now becomes, multiply everything together. So I have 380 times 1.0 times 10 power minus 2, which is the same thing as exponential minus 2 times 65.79. So I have 250.002. So approximately 250. So what is now going to be the SI unit? Since Q, which is the quantity of heat, is in joules and T is in seconds, the unit becomes what? Joules per second. Or you can write what? Watts as the unit. So this gives us the what? The quantity of heat passing through the material per second. So let's look at another second example under the thermal conductivity of a material. Okay, so this is the second example we have under the thermal conductivity of a material. Now the question says that a thermal conductor of length 0.5 meters loses 3000 joules of heat in 300 seconds when the temperatures at the ends are 100 degrees Celsius and 80 degrees Celsius, respectively. Calculate the thermal conductivity if the area of the cross section is 1.5 times 10 power minus 2 meters. All right, solution. Okay, so let's write down the parameters from the question. We are told that a thermal conductor of length 0.5 meters. That is the what? The length of the material. So L is 0.5 meters. Okay, and it loses 3000 joules of heat in 300 seconds. So 3000 joules of heat, that is the quantity of heat that is being transferred or that is being lost. So that is Q is equals 3000 joules in 300 seconds. That is the what? The time taken. So T is 300 seconds. Okay, so when the temperatures at the ends are 100 degrees Celsius and 80 degrees Celsius. So 100 degrees Celsius, that is the initial temperature, which is what? T1. So T1 is 100 degrees Celsius and 80 degrees Celsius, that is T2, is 80 degrees Celsius. So we are asked to calculate the thermal conductivity. So what is that? K. We are looking for the thermal conductivity, K, of the material. Okay, so we are given the area of the material A to be equals 1.5 times 10 power minus 2 meters. All right, so let's go ahead to find the value of the thermal conductivity of the material. Okay, so we know that the quantity of heat, Q over T, is equals Ka into T1 minus T2 over L. Okay, so let's substitute the values in order to find the value of K. All right, so Q we know is given to be 3,000. So 3,000 divided T, which is given to be 300. And it's equals to K, which is the unknown variable, multiplied by A, which is the area. And the area is given to be 1.5 times 10 power minus 2 times T1 minus T2. And our T1 is given to be 100 and T2 is 80 degrees Celsius. So we have 100 minus 80 divided by the L, which is the length of the conductor, and we are given to be 0.5. Okay, so we have 3,000 divided 300. That gives us 10 to be equals K times 1.5 times 10 power minus 2 times 100 minus 80, that is 20 divided 0.5. Okay, so we have 10 to be equals K times 1.5 times 10 power minus 2 times 20 divided by 0.5, that is 40. All right, so we have 10 to be equals K times 1.5 times 10 power minus 2 times 40. So I will use my calculator to evaluate that. So I have 1.5 exponential minus 2 times 40. So that gives me 0.6. Okay, so we're looking for K, so we divide both sides by 0.6. So that makes us to have K to be 10 divided 0.6. And K will now be, so we have 10 divided 0.6, which is equals 16.67 approximately. And the SI units, we have watt per meter per Kelvin. So this gives us the what? The value of the constant, which is the thermal conductivity of the material. All right, thanks for watching. Please make sure you like and subscribe to my channel for more videos like this. If you have questions, let me have them in the comment section and I will reply to you. Bye.